Good morning, everyone, and welcome to today's webinar, where we're going to be discussing export limitation. We're going to be talking about G100 requirements and also looking at third-party Modbus control for PV installations. Quick introductions. My name is David Porter. I'm one of the technical advisors here at Fronius, so supporting installers and EPCs with the system design, training, installation, and commissioning. And I'm joined on the presentation today by Andrea Waller, who is our marketing and FSP coordinator. So the very first question we shall ask is, what is export limitation? Well, this is a limit that's placed on the system, restricting the export back to the grid due to grid infrastructure being unable to cope with the excessive amount of power being generated by PV systems. This could be, for example, because one large PV installation in an area has taken all of the capacity, so any other additional sites that are installed are restricted, or it could be because a system is in a rural area or far from a transmission line, which means that it has a weaker infrastructure and it's unable to push a lot of power back to that transformer network. So without grid reinforcement, this issue will only get worse. We'll have more PV systems installed around the country. We'll see less and less additional export capacity available. So more and more systems will require export limitation. Of course, customers could pay to have that local area grid reinforced. However, this is normally a very expensive process, tens, if not hundreds of thousands or millions of pounds to undertake this work. So normally it's not a viable process. It would be better just to export limit that system. And of course, now with the new fast track export limitation requirements with the SIG scheme, so we can install larger PV installations on residential properties and normally only have a 10-day turnaround. This means that we can install maybe a 10 kilowatt inverter or an 8 kilowatt inverter and export limit that to 16 amps per phase, which is 3.6 kilowatts. And this is becoming quite an interesting option for a lot of installers. So how does this work? Let's have a look at a typical PV system with full export. Let's say we have a nice big PV system on this house, 10 kilowatt array, and we've connected that to an 8 kilowatt inverter. During the daytime, there may be nobody in the property, so we're only using 1 kilowatt's worth of energy on site, and the rest of that energy is being fed back to the grid, so 7 kilowatts going back to the grid. Well, that's absolutely fine if you have a connection agreement that allows full export. However, typically now, with the new SGI fast track connection agreements, we're limiting the system automatically to 3.6 kilowatts. So that means the same system with a 10 kilowatt PV array now sees the inverter limited down to 4.6 kilowatts. Of course, 1 kilowatt is still being used in the building, but only 3.6 going back to the grid. So the inverter has to throttle back its output. And this is done using our Fronius smart meter, which is analyzing the energy being imported and exported, and that instructs the inverter what to do, how to react, how to throttle back the output. Of course, if we lose communications with that meter, we don't know what energy is going back to the grid. We also don't know what energy is being used in the building. So the inverter has to go into a fail-safe mode. Now, of course, if we have a 3.6 kilowatt limit, the inverter can ramp down to 3.6 kilowatts. And even in the worst case scenario where no energy is being used in the building, it can still feed back that 3.6 kilowatts to the grid with no issues. So fail-safe mode does still allow export of energy back to the grid, but only up to the export limit. Of course, if you have a zero export system, you're not allowed to put any energy back to the grid, and you can see some very severe limitations put on the inverter. So if we only have a small load in the building, the inverter is only able to work to a very small output. Of course, we can improve this situation by adding something like a battery. So we can then charge that battery up with the surplus energy, increase the generation during the day. If that battery is full, we can of course then charge up an electric vehicle and potentially heat hot water as well. So by adding extra smart components to the system, you're able to still maintain the zero export but you can get a lot more power out of an existing PV system, just being smart with how you distribute that energy within the property. So it'd be quite interesting to know your experiences at the moment. How often are you having to export limit your installations? So just a very quick poll question. How many of your recent projects have been export limited? Just launch the poll for you now. So are you finding very few of your PV installations are export limited, none or just up to 20%? Are some of them occasionally being requiring it? I find about half. Most of your installs or these days is practically everything you do export limited. Be very interesting to see the feedback. Let's close that poll and have a look at the results. Okay, so some interesting results there. So good to see. There's still a lot of full export sites out there. That's really good to know. But we are starting to see more and more requiring the export limitation. And if you are going to go for that SGI fast track approach, then you'll probably see most of your installations in future requiring the export limitation. So thank you very much for that information. I think probably this time next year, we may be seeing at least half of the installations, if not more, requiring the export limit. And of course, one of the things we'll also see is different regions of the country are more severely affected by this. So there may be some regions where there is good, strong grid infrastructure, and there are other parts of the country where we're really severely limited now. Okay, thank you. So let's have a look at our Gen 24 and Toro export limitation. So we simply export the limit, the inverter, by connecting the smart meter, which analyzes the energy being exported and imported. However, with the Toro and the Gen 24, we can there is no inverter to inverter communications. So when we have our monitoring set up, each individual inverter has a connection back to a router and then to the internet. So this means that we are limiting just one inverter per system. So this isn't necessarily a major issue because, for example, if we have two inverters in the house, what we can do is have one larger unit, maybe a 10 kilowatt Gen 24, and then a smaller 3.6, which is unrestricted. And of course, if we have a 3.6 kilowatt limit, this inverter can run unrestricted, and all of the export limitation is done on that bigger inverter, which might also have a battery connected. So normally we can find a workaround if we have to have multiple inverters on the site with an export limitation. So how do we enable the export limit with these inverters? Well, we do it through the web user interface for the Gen 24 and Toro, and we use a mobile phone with the Solar Start app. So download the Solar Start app onto your phone, then go to your inverter, press the optical button on the front of the device. Once you've done that, it will flash blue, which means that the Wi-Fi access point is enabled. Connect to the Wi-Fi network within your phone and launch Solar Start. You'll then be taken to the commissioning process. And if we go into the product section, you'll be asked to give the system a name, a time zone, choose the time zone, and set the grid setup for where you're installing. You can then click the next button. You'll add the devices into the system. So we'll be adding a PV generator. That's the panels on the roof. So we tell the inverter what's actually installed up on the roof. So let's say we have a 4 kilowatt PV array. Enter in the 4 kilowatts, click the add button, and you'll see that the PV generator is now listed as a component. We also need to add our power meter. So again, add that device, hit the add button, and you'll see we've now got the generator and the primary meter selected in our devices. Click next. The next section, functions and IOs. This is for controlling relays or taking input signals to your inverter. We don't need any of this for export limitation. So for now, we leave those switched off. And finally, we go on to the export limitation section. So as a default, the export limitation is always switched off, and you need to enable it here from the drop down. And we have two options. We have limit the entire system, or limit per phase. So if you have a 3-phase installation, you'll see some asymmetry between the phases. You'll probably see one phase will be exporting, maybe the other 2 phases are importing energy. Using the limit per phase option, we'll always focus on the weakest phase, the phase that's first going to be exporting energy. So it means that none of the phases will ever export energy potentially. Whereas with limit entire system, you're looking at the net sum of the 3 phases. So if you have 1 phase exporting and 2 phases importing, you'll add the energy of the imported phases and then subtract the exported energy. So you're looking at the sum total of the 3 phases. And this is the approach that we usually use in the UK market. So choose the limit for entire system, and then also set in here your DC power. So again, we said 4,000 watts, maybe on the roof in this instance. And we can choose either an export limit protection. This is a hard limit. This will trip out the inverter if you go beyond the threshold. Or you can set an export limit control, which will dynamically throttle back the output of the inverter. This is known as the soft limit. And again, in the UK, we're using this soft limit usually. You would only normally set the hard limit if you have a really severe requirement to limit export. You could set that also as a second level of protection if necessary. But usually we just use the soft limit, and we set here the maximum grid feed-in power. Domestic install, let's say 3,680 watts. The final option at the bottom here is to reduce inverter power to 0% if the meter connection has been lost. If you have 1 inverter in the system, you don't need to check this, because remember, if we have a loss of communications between the meter and the inverter, that inverter in fail-safe mode can still export the 3.6 kilowatts. It can still generate 3.6 kilowatts, that's fine. But if there's a second inverter, or maybe a wind turbine or another generation device, we don't know what that's doing. So if there's no meter, we don't know what's going back to the grid, and we don't know what that second inverter is doing. So where there is multiple inverters in the system, we need to turn on this reduce inverter power to 0% if meter connection has been lost. So just to reiterate that, 1 inverter, you can leave this switched off. 2 or more generators, turn that on. Click finish, and you're back to your commissioning process. So that is the process for export limiting a Gen 24 or a Toro inverter. Let's have a quick look at the export limitation on the snap inverters. So even though these inverters are tried and tested, they've been around for 8 or 9 years now, we still have the ability to export limit, and they have actually one real benefit at the moment, which is we can daisy chain these inverters together, and we can export limit multiple devices from one Fronius data manager. So the meter connects to the data manager, and that is able to control multiple units. We can connect 100 inverters to one data manager, but the more you add, the slower the communications get. So we normally recommend up to 6 per data manager for export limitation. However, I have got systems out in the field with over 40 inverters, all controlled by one unit, and that works quite happily. Bad news, unfortunately, is we don't yet have the certification for G100 on these inverters. So even though we've been doing this for many years and we have many systems installed, export limited under G100/1, the current certification is still being prepared by our R&D team. They have to do further testing, they have to provide new documentation, and unfortunately, that's taken quite some time. So we're waiting, and we should have that early next year. In the meantime, you could still install these inverters with export limitation, provided that it's installed behind a reverse power relay. And we'll talk about reverse power relays a little bit later. So I mentioned G100 a few times. What is it? Well, this is the engineering recommendations that cover both export of energy and import, and limiting export and import. So this is specifically for the UK. So anyone viewing from the Republic of Ireland or any other markets, the good news is this doesn't affect you. So snap inverter export limitation is absolutely fine in your market. This is just covering the UK and Northern Ireland. And it defines the requirements of something called a CLS, a customer export or import limitation scheme. So this is the solution for limiting the export. And what we have to do is we have to adhere to three main different states of operation. So state one is our normal operation, where the system is working normally. Export is below the threshold, and we're adhering to the requirements. State two is where we have occasional excursions. So we're exceeding the export limit, but the inverter is reacting, it's reducing the output and getting back down to the required threshold. And we're not exceeding, we're not in state two for more than 10 seconds. We then go to state three, which is a failed state where we're above the threshold for more than 10 seconds. And we're expected then to enter into a fail-safe mode. So we talked about fail-safe earlier. This could be, for example, if somebody's cut the cable to the meter or disconnected the meter, the inverter knows there's a problem, reduces the output and avoids exporting excessive energy back to the grid. So those are the main requirements of G102 that are different to G101. We also have to provide a cybersecurity statement, and that is to show that we're adherent to regulations and standards within the UK. And obviously, Fronius being a European manufacturer, we hold all of our data securely within the European Union, so we adhere to those requirements. If you look at the scheme shown up on the screen here, it looks very complicated. We see various controllable loads. Well, that could potentially be something like an EV charger or a hot water immersion device that we can control. We have our generation devices, our inverters, and we could have a storage device. So this could be an AC battery or even a hybrid battery that can draw energy from the grid and potentially export energy to the grid. And then in orange, we have our CLS, our components in our limitation scheme. Well, that all looks very complicated. In reality, that is just our Fronius smart meter, our ULWR smart meter. So it's a lot simpler than it looks. And if you want to find out more information on this, if you're struggling to sleep and want some light reading at night, then you can certainly download the engineering recommendations from our handout section on the right-hand side of the screen. That gives you all the data, all the details required for that. It does also explain the witness testing process procedure if you do need to have any systems witness tested as well. So it's useful for anyone technical to have a copy of. So just to confirm where we stand with the solutions currently, we can limit a single Gen 24 and we can limit a single Toro, and they're both G100 certified as well. So you can download our declaration documents there, which you can submit with your DNO applications. Please feel free to download that document. We're expecting next year to be able to provide Modbus limitation of multiple devices, so multiple Gen 24s and Toros. So that's scheduled for midway through next year. And once that's released as a firmware update for the inverters, we'll also then be doing the testing for the G100 and the release of the documentation for that. Multiple inverters, multiple snap inverters, that is already possible. So if you're in the Republic of Ireland and in other markets, you can do that right away. The testing is scheduled for that in Q1 next year. So for G100, we should be able to do that fairly early next year. And then finally, mixed systems with all the different inverters connected. The good news is that is due to be possible in mid-2024 as well. So similar situation to Toro Gen 24 systems. And that again will be using Modbus, which is the communications protocol. So of course, some of you are looking at some quite large systems, complex installations or mixed installations currently, and you might be thinking, oh God, we're not going to be able to do that because of this G100 issue. Well, the good news is there is a solution. We can control the systems right now using plant controllers, and these are third-party export limitation systems, which will enable you to install the Fronius inverters, the mixed systems, the big systems, and export limit those. But what is a plant controller? Well, it is a third-party device which is able to provide data logging. It communicates with a meter, normally its own meter rather than a Fronius one, and then it provides the control of our system using Modbus communications. There's a couple of internationally well-known devices from Meteor Control and SolarLog, which are available off the shelf from PV distributors that are able to provide this communications and provide this control. But we also have a company in the UK called Pad Technology, who have been with us in Milton Keynes testing with our inverters with mixed systems, and their solution has been designed specifically for the UK market, so that's a real benefit. And also they can use our Fronius smart meter, so they can use the data from our meter, meaning you don't have to buy a second smart meter from another company. Again, we have some information from the handout section. There's a white paper available there, which gives you a bit more information on the system. I keep using this word Modbus, just to give you a bit of information on what Modbus is. It's a very common communications protocol used between different machines, and it's been available since the 1970s. And the main version of that is known as RTU, Remote Terminal Unit. So this is where we have a master device, which is the plant controller, and that sends instructions to a slave device, which would be the inverters. There is also the option of TCP, which is Transmission Control Protocol, and this is using a LAN connection rather than a dedicated RS485 connection, and so we can communicate as well just over a local area network using Ethernet cables. So there's two ways of connecting the system together. And it's always a case that the master and the slaves can communicate with one another, but the slave units, the inverters, don't talk to one another. And we also have a situation where the master unit has Modbus ID 0, which is a broadcast. That means it sends the signal to all the devices at the same time. So it's a nice, fast way of communicating with the devices. Where are the Modbus connections on the inverters? Well, we have our RS485, our RTU connection on this Modbus block here. So you can see we have two connections. So if you did have a battery and you did have third-party communications, you have two sets of connections, so you can have those multiple devices if necessary. We also have our LAN port here for connecting to the internet. So if you're using the TCP option, you just connect onto LAN port 1. And how does that look in the layout of the system? Well, with TCP, so using the LAN connections, we just have the connections back to our router, maybe an Ethernet switch, and then our plant controller and its meter also connected there. So quite a simple setup. But with the RTU connection, so this is using the RS485, the 3-core cable going to the two individual or multiple inverters. We have those as additional cables. That's its own cable, a bit like the smart meter or a bit like a battery has its own Modbus cable. You can still connect it to the internet through the LAN port, but this is a dedicated communications path for the export limitation. And we would normally recommend using Modbus RTU because this is a fast communication. It's sending a broadcast signal to all the inverters at the same time, and they're able to then react very quickly. So this is the best option for export limitation. And as I mentioned before, when we were talking about the multiple snap inverters, we normally need to install a reverse power relay if we don't have grid protection or we don't have G100 protection built in and certified on the plant controller. So the reverse power relay sits in a similar position to the smart meter, monitoring the imported and exported energy. And if we see that we're exceeding the export limit, this works as a fail-safe, and it opens up AC contactors, switching off the inverters protecting the system and providing you with the export limitation fail-safe. So most of the DNOs are quite happy to have this as like a belt and braces option to provide the export limitation. And then we also obviously then have the dynamic limitation of the inverters as well. So we keep the inverters alive, throttling them back rather than hard switching them on and off. But then if we do have an issue with the system, we have that backup protection. We have that fail-safe protection here, which switches the inverters off if there is some sort of failure. So the good news is that if you have a plant controller, you can already install any combination of inverters that you require, but please check with the supplier the situation with their G100 compliance. You may need to install that reverse power relay in addition to provide the complete fail-safe protection. So let's have a quick summary of what we've just seen. We can, of course, install a single Gen 24 or a single Toro unit with G100 export limitation right now. That is controlling a single inverter, but it can also be used in a multi-inverter situation, provided that the rest of the inverters will not exceed the export limit. The snap inverters are already able to provide export limitation, but we're waiting on the certification for those. But that's not a problem for the Republic of Ireland. You have compliancy with the NC7 requirements already, so you're good to go with the snap inverters. The Modbus control can be used in future. It's currently in development for controlling multiple devices, and we can't wait to have that. That's going to be a real benefit to us. But in the meantime, plant controllers can be used for export limitation of those larger installations, or those multi-inverter systems. And don't forget, you may need to be installing a reverse power relay for fail-safe protection alongside the plant controller or the data manager because it's not yet certified. And please do confirm with the DNO if they're happy with that solution. They may ask for a witness test just to prove the system. Okay, let's have a quick look to see if we have any questions. Andrea, do we have any questions?
Yes, we do. Yes, yeah. The first one from Rowan is, how do you know when to use soft or hard limit?
Yep. So I think we mentioned the soft limit is throttling back the inverter. The hard limit is switching off the device. Hard, basically turning the AC output off. So in the UK, we use the soft limit normally. Hard limit would only be required if there was a strict requirement. Maybe you're getting to the limit of the cable current carrying capacity, and you want to make sure that you have that protection in place.
Thank you, David. And then there's a couple of questions on the PadTech plant controller.
Yep.
Have we got an indication of the price for it, and also is it an off-the-shelf product yet, please?
So from the conversations I've had with Pad, they normally build that to specifications. So depending on the number of inverters you're controlling, so the price will vary. If you're just using the control unit, it's a few £100. If you also have the relay protection, it will depend on the size of the breakers you're installing, how many inverters you're controlling. But I think we've looked at systems that are sort of between £1,000 and £2,000 for quite sophisticated solutions there for larger installations. But it's best to speak to them directly because they'll be able to specify the right components for the system.
Okay, thank you. Another question, when does G100 2 become applicable in the UK?
Unfortunately, it became applicable a year and a half ago. So it was released in May 22. It then became a requirement this year. And of course, the focus for us was to get the Toro and the Gen 24, which are sort of like our long-term products, compliant. And then, unfortunately, it has taken just that bit longer to get the data manager systems compliant. But it is required for all systems right now.
Okay, thank you. And one more question. Andrew has asked for a link for a 5 inverter example, please, if that's possible.
Yes, so I assume that's for connecting with a plant controller. I think we probably have some. Well, I'll have to speak with Pad Technology, see if we have some example. Yeah, I'll check to see if we have some example schematics from them. I can certainly provide some examples from Meteo Control and from Solar Log as well, from their manuals, which show how to connect. But basically, it is just connecting onto their existing Modbus terminals on the device. But yes, we'll certainly see what we can get together for you.
Lovely, thank you. One more. So all witness tests should be to G100 2 at the moment. So if fitting 10 SIMO and 3 Toro, then they are not compatible without fitting an additional device. More cost? Question mark.
So yeah, it depends whether we can provide the export limitation with just one inverter, or whether we need to control all of those units. But if we do need to control those units, there are additional components that are required. Yeah. But what I would suggest is, if following this call, if anyone wants to send some information through on specific projects, send them through to our tech support. We can then have a look at those. We can advise on the best solution.
Great, thank you. I think that's all of the questions. Thank you.
Fantastic, that's great. Just before we end today's session, just want to make everyone aware we are looking at running an external G99 and 100 training course next year. So this will potentially be a day-long course held at Fronius in the UK, and will be provided by an external expert trainer, and we'll be running through the latest requirements for G100 as well as G99, and we'll also go through the application processes for G99 and G100. So once the dates and costs have been confirmed, we will provide that information out to everyone on today's call. And if you're interested, obviously, as you've shown an interest in this webinar, we'll give you first invitations on that training, but we'll let you know more information as and when we have that for you. And also, don't forget, if you have any interest in undertaking more training with Fronius, we have our e-Academy, our modular training. So if you have a SolarWeb account, you can go straight to the e-Academy, enroll there, and you'll be able to see all the various different modules and pick out the stuff that's most interesting to you. And of course, if you complete everything, that's the equivalent of FSP Day 1, so you can then come and undertake our Day 2 FSP training. So thank you very much, everyone, for your attention for this course, and thank you as well, Andrea, for helping with the questions. We will be running some more webinars in the next upcoming months, so hopefully we will see you all again soon.